Lesson 3-4, multiplying fractions. Complete the equation and or figure like the one shown. In this example, 3/4 times 5/6 equals 15/24. This multiplication equation is being shown to us visually in this model, but let me explain the model. 3/4 times 5/6 is like saying, what's 3/4 of 5/6? Let's say this entire model represents a whole. Now, let's say I wanted to show 5/6 of a whole. I would divide this whole into 6 equal parts, and I would label 5 of those 6 parts. That's what the circles represent. The circles show us 5/6 of a whole. So this could be 1/6, 2/6, 3/6 or a half, 4/6, 5/6, and then 6/6 or a whole. Okay, and of course this would be the 0. Now, let's say within each of those sections that I have circled to show 5/6 of a whole, I have shaded in 3/4. Now my model shows not just 5/6 of a whole, but within that, 3/4 of 5/6. Now, the reason that you see 24 as the denominator is because within each of these 6 sections, I have divided each of those 6 sections or those circled sections into 4 equal parts. And 1/4 of 1/6 is 1/24. So each of these is 1/24. So now if I'm trying to prove that 3/4 of 5/6 really is 15/24, I just count up these shaded bars. 3/24, 4, 5, 6/24, 7, 8, 9/24, 10, 11, 12/24, 13, 14, 15/24. Sure enough, checks out. Let's try one together. 2/5 times 3/4. Okay, first we're going to use the circles to represent 3/4 of a whole. I've got my whole. I've divided it up into 4 equal parts. 0, 1/4, 2/4 or a half, 3/4, 4/4 or a whole. Circled off 3/4. Now, within each of these circled sections, I am shading in 2/5 of each section. So I'm taking this, dividing it into 5 equal parts, shading in 2 of those, shading in 2, shading in 2. Notice how I have labeled this in terms of 20ths now, because for each of these circled parts, which represents 1/4, I've divided that into 5 equal parts. So 1/4, if I'd have to divide or find what 1/5 of 1/4, get a 20th. So each of these is 1/20th. Because again, I've taken 1/4 of the whole and divided that into 5 equal parts. So now we'll count them up. 1/5, 2/5, 3/5, 4/5. Sorry, not fifths. 1/20th, 2/20th, 3/20th, 4/20th, 5/20th, 6/20th. Our answer here is 6/20th, which, can you simplify that? You notice that they're both even numbers. What you do to the top, you do to the bottom. We can divide them both by 2 and simplify this answer to be 3/10. Next problem, 2/3 times 6/7. Okay, so again, let's use circles to show the 6/7. And I'll label this 0, 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, 7/7 are a whole. I'm going to circle off 6 of those. Now my model shows 6/7, but I'm trying to then add on the 2/3. For each of these circled off sections, I need to show 2/3. So I'll take this, I'll divide this into 3 equal parts, shade it in. 3 equal parts, shade in 2 of them to show 2/3. 3 equal parts, shade in 2 of them. Okay, how am I going to label this? Each of these circled parts was 1/7. Now I've taken 1/7 and I've divided that into 3 equal parts. So each of these represents 1/21st, 1/21th, 21 equal parts. And I'm not going to keep labeling them. You get the point. Now, total them up. 1/21, 2/21, 3/21, 4/21, 5/21, 6/21, 7/21, 8/21, 9/21, 10/21, 11/21, 12/21. To summarize this section, what we have done to conceptually show a model of multiplying two fractions together is we've first taken a whole and we have visually created a model of one of those fractions, and then we've basically overlaid the second fraction. So for each of these fractional parts that go with one of the fractions, we've overlaid the second fraction. You'll see another way of doing that this time, and this is called the area model. Number 3 says solve using the area model, 6/10 times 2/3. So look, first imagine that this is 0, 1/3, 2/3, 3/3, and imagine that this part that I'm outlining represents the 2/3. Now, imagine that I am overlaying on this model, not vertically, or sorry, not horizontally, but vertically, I'm overlaying 6/10. So I'm taking the whole, I'm dividing it into 10 equal parts, and I'm shading in 6 of them. Where these two columns, the 2/3, overlap with these 6 rows is the answer to my multiplication problem. That overlapped region is the answer. So, well, what does each of these tiny parts represent? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 30 of these boxes. So each of these boxes is 1/30th. So how many tiny boxes do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12/30ths. But I can simplify that. 6 is the greatest common factor. I can divide the top and bottom by 6 to get 2/5. I gotta be honest, the area model, I don't really care for it. It is just another way of showing the concept of multiplying one fraction by another. This time for number 4, I'll try to show you the area model, but then I'm going to get into the traditional method of how I want you to multiply fractions, and I'm going to go back and use that method for each of these practice problems. And I think you're going to like that one a lot better. 3/5 times 7/9. Okay, well, look, let's show 7/9 first. And somehow I have to try to show 7/9, and I'll try 3, 4, 5, 6, 7, 8, 9. Okay. Now I'm going to shade in 7 nines. 3, 4, 5, 6, 7 nines. Okay. Actually, that's not good shading. Okay, now I'm going to get a little sloppy. That's going to have to do. Now I want to overlay 3/5. Okay. So overlay 3/5, 1/5, 2/5, 3/5, 4/5, and 5/5. Where these two overlap is the answer to my problem. So that's my overlap. Why? Well, from left to right, I showed 7 ninths. From top to bottom, I showed 1, 2, 3/5. Where those two overlapped is my answer. What do each of these tiny boxes mean? Well, I have 9 going this way. I've got 5 going this way. So each of them is, the whole is split up into 45 parts. Whole is divided into 45 parts. So how many do we have? Well, I've got 7 going this way, and I've got 3 this way. 7 times 3, I get 21 over 45. 3 is the greatest common factor. I can divide the top and bottom by 3 and get a final answer of 7/15. Now, I'm going to show you the way that I want you to solve these problems. When you see 3/5 multiplied by 7 ninths, multiply the numerators together. 3 times 7 is 21. Multiply the denominators together. 5 times 9 is 45. And then ask yourself, is this answer in simplest form? In this case, it's not, because 3 is a common factor that goes into both numbers. I can divide the top and bottom by 3 to get my simplest answer. Up here, 6/10 times 2/3, multiply the numerators together. 6 times 2 is 12. Multiply the denominators. 10 times 3 is 30. Ask yourself, is this answer in simplest form? It is not. I can divide the top and bottom by 6 to get a final answer of 2/5. Number 2, 2/3 times 6/7. 2 multiplied by 6 is 12. 3 multiplied by 7 is 21. 12 over 21. Number 1, 2/5 times 3/4. 2 times 3 is 6. 5 times 4 is 20. And we already discussed how we can simplify or reduce this answer to 3/10. So all of this conceptual model business is fine. And it is a part of your 5th grade study of these skills in math. But to be practical, when you are actually given a problem like 6/10 times 2/3, I do not expect you to take the time to create this kind of a model and count up all these boxes. It is much more straightforward to multiply numerators, multiply denominators, and then ask yourself, is my answer in simplest form?